This is one of the best places in the world to learn physics. You really like the subject of physics, or you like the kinds of things that physics reveals in the world and you want to learn more about it, then this is one of the best places to be. It's always easier to do things that you enjoy. There are usually 3 interviews. 2 of them would be in the college that you're assigned to or that you applied for, and then 1 would be at a random 3rd college. And within this college, 1 would be physics-based, the other would be primarily maths-based. Probably physics and maths both together, or one or the other. The normal format for a physics interview is, today he was interviewed by only myself. Usually there's another person in the room. I would introduce the other person as well. One would probably ask most of the questions and the other would take notes. And that's fairly typical to the way that these things go. What you wear makes absolutely no difference. I do remember one young man who, the entire time I saw him, he had various heavy metal rock band t-shirts on, and that was including at the interview, which doesn't bother me at all. You may have written the personal statement quite a number of months ago, okay? But it would be a good idea to refresh your memory about the book that you've put in, because one of the opening lines that often can happen is, oh, well, I've read that book as well. Can you tell me something in that book that you found interesting? And then to be unable to pick anything at all out of that book that you supposedly have read isn't a good way to open an interview. Right? You know, I know it's been a long time, but just pick the book up again. You know, read through a few of the pages, refresh your memory as to what was in the book. Try, I know it's difficult, but try to relax. Can you tell me a little bit about your school and the course that you were on?
I'm doing A-levels, and so I did maths, further maths, physics, and chemistry.
When you're interviewing and you're asked the questions, the physics or the maths questions, do not be afraid to talk out what you're thinking.
So the rotational frequency,
Yeah.
The omega.
Yeah. And so what units have you got there so far?
So this would be kilograms, and omega's radians per second, so just per second.
Mm-hmm. Okay.
When you omega squared to get per second squared. Right?
There you go. Mm-hmm.
I get -2. Now I just need meters squared.
Yeah.
I guess for a spinning circle, it'd be the radius of that circle.
Okay.
Yeah.
So that's your guess.
Yes.
Meters radius of the bicycle tire squared.
Yeah.
Times.
So that will give a meter
yeah.
squared term.
Yeah. Okay.
So m omega squared r squared.
Mm-hmm.
Right.
Yeah, that's pretty close. Right?
Okay.
I mean, the only thing you missed is the arbitrary factor of a half. That.
Oh yeah.
Right. But that would be the rotational energy.
Don't freak out if you don't immediately know how to start solving a question. It's not going to be straightforward. It's okay to ask the tutor for advice on where to get started.
Do you know what the energy term for rotational kinetic energy would be?
I don't know what the...
Okay. He stumbled in places I thought he might stumble a bit, but, recovered well. What are the units of kinetic energy?
Joules, which is kilogram mass v squared, so kilograms, meters squared per second squared.
Yeah, you might want to write that down. You cannot be an equation hunter. This is a term I use. I see it happen a lot, where a candidate might think they can show us how brilliant they are by instantly coming up with the answer. That will not be possible. We have asked a question that you must work through, and that often requires multiple lines of inquiry, combinations of things like conservation of energy and conservation of momentum and forces and uniform circular motion, all combined together into one problem. You will not be able to do it by hunting for equations, trying to find the one that fits, and then substituting the numbers in. That will not work. we're looking for a deeper understanding, a deeper physical intuition than simply being able to memorize a load of equations and then figure out how to attach an equation to a given question. Does that make sense to you?
Yeah.
Why? It's one of the first things that I look to see, and it's easy to spot. Don't be afraid to draw great big diagrams. I see this a lot where a student comes in and you'll present to them a problem that works really well in picture form, and then they'll draw a tiny little picture in the corner with not any room to actually, add anything onto it. We have lots of paper. Use the whole page if you have to. Right? We'll just give you more pages. It will be fine. This probably varies depending on who's interviewing in specifics. In my case, consistently we've seen that the physics aptitude test is one of the best indicators for how well a candidate's going to do when they actually come on the course. But that is simply one test that occurs on one day and lasts for a few hours. And anybody can have a bad day and anybody can have a good day, right? But if they happen to have had a bad day on that test, then one of the things I'm trying to do in an interview is to try to find out if I think they actually have a deeper physical intuition than this PAT test can reveal. Suppose someone, managed to get, in excess of 80 to 90% on the physics aptitude test, and then they came in and they didn't do very well at all in interview. That would be really tough. I think they would have to do badly in all of the interviews in order to then not be taken. Studying for that physics aptitude test is a worthy goal. We have a whole website which is publicly available in physics with all of the past PAT tests. Do them.
I prepared by looking at questions in physics that go beyond typical A-level questions, with similar concepts that in A-level but make you think in a different way, or they're just less straightforward in general.
Try to do them as quickly as you can, and try to place an equal emphasis on the math section and the physics section. And think about strategy. You have one block of time to do the whole thing. It is not a good idea to spend all of your time on one section or on the other one. We're looking for a balanced approach. And good luck.